you don't have a copy of Note 6, come and get it. Right here.
That's debatable.
Anybody else need Note 6?
I'm not interested. I know, but you're not a woman.
Dylan, you got Note 6?
I do, but I need my quiz.
I'll give you the quiz at the end of the class. Okay, let's do Note 6. Full wave, 2 diodes, rectifier circuit. So now, let's draw the circuit diagram of a 2 diode rectifier circuit. Right beside the title, where it says 2 diodes rectifier circuit. Can you write down the words CT? So right at the top of Note 6, can you write CT and write the word center tap? I'll explain to you in a minute what that means. So all full wave 2 diode rectifier circuits use a center tap transformer. So in my circuit diagram that I'm going to draw on page 1, I'll start out with a transformer on the primary side with the primary winding. So this is the diagram I want all of you to draw. And you will notice that unlike other teachers, I insist I want you to become good sketchers of circuit diagrams, okay? You want to be able to sketch a circuit diagram that you'll be working with. So you've got a primary winding, you've got a secondary winding. And it's going to have a center tap, which means that right at the middle of your windings, you're going to go right to the middle and bring a 3rd wire out. So you have 1, 2, and 3. 3 wires coming out from the transformer, center tap transformer. And this being a 2 diode rectifier circuit, we're going to put the first diode right here, D1, and we'll put the second diode right here, D2. This is always the case. You put the 2 diodes at the 2 end wires of the transformer, not on the center tap. Okay? Then, you connect the 2 cathode sides, anode, cathode, anode, cathode. You connect the 2 cathode sides together like this. And you connect this point to the center tap is where you connect the load. If the load is a light bulb, that's where you connect the light bulb. If it is a motor, that's where you connect the motor. If it is a resistor, that's what you do. Okay, so this is how you wire up a 2 diode rectifier circuit. In my example, primary winding voltage is 120 volts, 60 hertz. Transformer has a turns ratio of 15 to 1. I'm using the same transformer as the previous notes. The resistor is 1K. Let's first understand what's happening in this circuit. How does this work? Well, let me explain what's happening. I start out with a high primary voltage, right? It gets lowered on the secondary side, becomes a smaller voltage. right? But it's still a full sine wave. That voltage here is going to be split up into two voltages. I'll have one voltage here and another voltage here. Okay? AC voltages at two resistors get split up into two voltages, but it still remains AC. The same thing happens at the transformer. I've got one voltage from 1 to 2 and another voltage from 2 to 3. They'll both be the same values because the connection is to the center of the transformer. So, now let's see what happens. Positive half cycle. This is a positive half cycle, which is equivalent on the secondary side with a positive half cycle there, with a positive half cycle there, and a positive half cycle there. So what that means, that positive half cycle means that as far as the polarity at the transformer, I've got plus here and minus, plus here and minus. Okay, that's what that means for the positive half cycle. So, for the positive half, let's look at the diodes. D1, is it forward biased or reverse biased?
Forward.
Forward. D2, plus minus,
Reverse.
reverse, which means that this guy acts like a closed switch with a 0.7 drop across it. This guy acts like an open switch. If it's open, there's no current flowing this way, but with diode D1 acting like a closed switch, you'll have a current that's going to flow from the plus through the diode to the minus, okay, through that load RL. So where the current comes in, plus, where the current comes out is minus. So that's the voltage at the resistor. Now, let's take the second case, negative half. Let's look at the negative half of my cycle. Here's the negative half, which means that on the secondary side, negative half, which means that my voltage is split up into one voltage up here, another voltage up here. So now I'm looking at the negative half. Polarity here, instead of plus minus, will be now minus plus. What about here? Same thing, minus plus. Okay? So that's the polarity at the transformer winding.